Hi, my name is Silas from AHX Finance, and today I'm going to be presenting to you the KESY bridge, which is a critical piece of infrastructure in our stablecoin ecosystem. KESY is a unique and one of its kind stablecoin in the region that is being pegged to the Kenyan shilling. It's currently being incubated by the largest securities exchange in Eastern and Central Africa in conjunction with the Hedera Hydra Foundation. Now, when issuing virtual assets in the region, such as stablecoin, we're going to be facing two major pain points: compliance and trust. Number one, regulators need to know that every transaction follows strict policy guidelines. And number two, users need to be assured of their safety through transparency. Luckily for us, Chainlink provides three major technologies that we have leveraged to address the issues mentioned. Number one, CCIP for secure cross-chain communication and messaging. Number two, ACE for institutional grade compliance, which is real-time. And number three, CRE for automation and orchestration of the compliance features that we have. Let's have a look at our smart contract architecture.
We are now at the GitHub page where we are hosting the code base for the bridge, the KESY bridge demo that we're going to be conducting. And from the README, you can see that we have a hub and spoke architecture where we are leveraging CRE for automated compliance enforcement. The main contract is the KESY Omni Bridge, which is deployable on both the hub and the spoke, serving the lock and ban and mute function. The key thing to note is the WKC contract, which is a policy protected ERC20 token, running obviously the ACE from Chainlink, which acts as the registry and the coordinator. The main policy that I want us to focus on is the reject policy. So the CRE workflow compliance syncs every 5 minutes. So it runs every 5 minutes, gets details of addresses from Hedera Mirror node, what addresses have been blocked, what addresses have been unblocked, which one have been wiped, etc. etc. It then calls the compliance consumer, which then ends up calling the reject policy. The reason why we cannot directly call the reject policy is because reject policy is an only owner a contract, so we had to do a workaround so that the CRE workflow can call the compliance consumer and then it can end up calling the reject policy. So one thing to note is that bridging takes 15 to 20 minutes. So when this workflow runs every 5 minutes, you can make it 30 seconds for even further security protection, so that by the time the user has the funds in their wallet, the compliance will have already run and it will have already determined whether the user can receive these funds or cannot receive the funds. We'll get to see this in the demo that we are going to do next. Also, we have some good documentation here. You can have a look of how we're using ACE, how we have protected the WKC with ACE, as I've mentioned before, and a bunch of other stuff like deploying this on your own. Let us now look at the live demo. So we are back, and right now we are on the KESY bridge page where users will be bridging from Hedera to any network and also any network back to Hedera. But right now, since the contract have only been deployed on Sepolia ETH, we are going to demonstrate that one. So you can see I have about 1 million test KESY on Hedera and also 100 on Sepolia ETH. So I'm going to say I want to bridge 50 of them. So I'll start by approving the allowance. Once the approve allowance transaction has gone through, I'll click bridge. I'll then take the transaction ID. I'll go to Chainlink CCIP Explorer. I'll copy paste that there. And you can see that this is going to take a while. So it's, for my testing, it's about 15 to 20 minutes. So we're going to pause on that and I'm going to show you the other CRE parts. Now, let's say for some reason that this particular Hedera user, who has about, I think it's 14 million KESY, unfortunate for him, maybe he has some kind of compliance issue and we want to freeze his assets or his KESY. So all we do, we'll come to our admin dashboard and then we'll just say test reasons for freezing. So reasons, and then we'll click freeze account. So this process will basically freeze his KESY on Hedera. However, it presents the challenge that maybe he already has more assets on Sepolia which he might use. So as you can see, I'll just refresh this page so that you can see that his assets are now frozen. However, this action is not translated to Sepolia. For Sepolia to be able to know that this particular user address was blocked or it was frozen, we need the CRE workflow to run, communicate with the compliance consumer contract, which we'll call the reject policy contract, which will then update our policy engine saying that, hey, this address is no longer allowed to transact. So what this cron trigger does is just it contacts the API or our personal API that we have took to the mirror node to return the most recent frozen transaction, as you can see here. So we are doing it on the KESY token. We're also noticing that this is the particular address that was frozen, and you can confirm that by cross-checking that this is the address that we froze on our admin dashboard. And then what this means that is that Sepolia now has this address as blacklisted. So in hindsight, this means that when we try to check with, for example, we have this method is rejected on our contract address on our policy engine. When we try to check if it's rejected, it will say that it's true. And to further confirm, when we try to send funds, when we try to send KESY to this particular address, which we have blocked via our policy engine, you will see that it will revert, and the reason for reversion will be address is on reject list. So basically, we have frozen both on the Hedera and on the Sepolia side. So for the final piece, so we have added some of these restrictions like the compliance issues and the whole freezing and unfreezing of an account. It's essential that the user gets to know when bridging, is it possible that I'm bridging to a potentially frozen address, or will this transaction go through? So with that in mind, we thought that we add an agentic bridging workflow that uses tenderly Virtualnets and Gemini 3 model from Google to simulate the transaction. So the transaction is simulated on tenderly, and then the response is sent back to the AI model. The AI model understands the transaction, obviously with all of our compliance settings in mind, and then communicates to the user in a natural language. So the idea is that the user will use this. If you noted that in our bridge, we had this tri-agentic bridging. So the user will communicate with the AI model from this particular chat interface. This chat interface will trigger this particular workflow. And then for our demo, obviously it needs a payload. Right now we're just using this dummy payload, but the payload will come from the user's end. So for now we'll just use the payload.json, but this will be passed as intent from the user, and it will be in JSON, and the AI model and the workflow will receive that. So you can notice that we are running some pre-flight check. We are checking the balance if everything will go through. We are checking if the user is blacklisted. We are checking if the receiver is blacklisted. So we are checking all of these things and then simulate the transaction. And then you can see that the transaction here goes through because I have enough KESY. I'm not blacklisted. Basically there's no hindrance to this transaction. So you'll see that the AI communicate a flight check and simulation. It will go through. It tries to simulate the cost, the gas cost, the confidence, obviously anything that you can think of in natural language. And then when I go to my Tenderly dashboard, you'll be able to see that. So I'll go to Explorer. You'll be able to see that this particular transaction went through. So this bridge went through. So the simulation went through. So the user will get that information and they'll be able to bridge successfully. Thank you. Hope you enjoyed the demo, and have a nice time.